Without further ado, I'd like to introduce Matt Hoy talking about data security and how to avoid an embarrassing breach.
All right, lots of people, not really, but get started here. You guys are actually going to be very, very lucky to see this because usually they bill me out at $400 an hour for this stuff. So this will be my third time speaking at LayerOne. I'm actually happy, and thanks to Datagram and all those people that run this con. My contact stuff is over here, and we're going to have an interesting talk about data security. And as I said, boy, is this one going to be special. I am currently not employed by anyone right now, so I don't have any gag. So this is just all about me, the me race. So I'm going to go ahead and break this down by talking about the history of data security, what changed, what a data security lifecycle is, data classification, and types of data. We're also going to go ahead and talk about how am I actually going to go ahead and solve this. Now, one of the things that I was doing in my first talk, I talked about IR, and it's kind of a losing battle where you don't actually have solutions that you can actually win with. Well, the nice thing about data security is you should be able to control your own environment to make sure that you don't lose it. And if you're not, it's kind of on you. But there are going to be some elements, very, very consulting-like people, processes, and technologies. I'm going to talk about what the industry standards are in relation to data security and management. And we're going to do a little bit of threat modeling and talk about some architecture. So why would you need data security? This is not that talk, but the thing of it is if you're not actually tracking what data it is, you don't actually have a chance in hell in actually making sure that you're going to be compliant. So we're going to go ahead and actually not delve into that, but I'll delve into the techniques of actually how you can track your data and actually understand where it's going to go. So this is always a fun one. What the hell are all these little words? So what I'm going to go ahead and do is tell you what they are. So DAR is data at rest. DIM is data in motion. DLP is data loss prevention. The hotness of today is UBA, user behavior analytics, in conjunction with taking the data, looking at how data is being used. PHI, protected health information. PII, personally identifiable information, and IP. So one of the things we fail to actually think about is how did we get here? Long time ago, computers actually weren't interconnected. And then came ARPANET, which was a concept in 1969, and it was actually put into place and went live in 1970. ARPANET changed ARPANET back and forth. I don't even know what it is anymore. But that meant universities and other researchers could go ahead and actually share all their research, share all their data, and as a result, we were in what was known as the Cold War. So essentially, all the security protocols that we had back in the day were based so that the Russians couldn't steal it. Now, as much as people give this a harsh criticism. I don't think that we've actually all learned from it being certified. If you passed, you actually should know this. So we go into the history of data security, and essentially there were two trains of thought. There was the Biba model, which essentially made sure that no matter what, if I was doing research, I was putting together plans, I was creating intellectual property, the data must always be correct. Cannot be wrong, because we would lose time and effort in actual research. It is known as the ability to read up, which is I can read up levels and I can only write down levels, and the fact that the highest authority as far as the publisher is always going to be right. The next one is actually of opposites. So when we look at this one, the underline in italics is that's corruption of data, essentially, and it's to prevent against any corruption of data. On the next side, we have we want to prevent leakage of this data. So the Bell-Padula model was created in 1972, and essentially it's a write up and read down. So when you're creating a document, essentially what this means is I'm a researcher, I'm working on missiles. I'm going to go ahead and make this document, and essentially I write it up. And then read down is you take your highest level, like a general or something, and they can read lower than that person who actually created the document. So you couldn't do anything else. So if I don't have clearance like a general to actually go read the specific data, I can only read at my own level. So essentially, even if it were classified, I can't look at it. So due to the Cold War, there were two things that were actually in place. We had multi-levels of security, and we actually don't have this anymore except for the defunct AS400 platform, and it's currently known as the I-Series. So what multi-level security or multiple levels of security basically ensure were that there is something called MAC, Mandatory Access User Control, which essentially took the Bell-Padula model and essentially made sure that you can't access data that you don't have the right credentials or security clearances to go ahead and access. So Cold War ended. We don't actually have these systems the way that they are anymore, but a few people still remember them. Another thing that we used to have back in the day is essentially there was a role. That role was called a data custodian. They actually were a job and were consisting of people. So if you remember any of that big-ass green bar paper, most likely a data custodian, those big printout things, a data custodian had to go ahead and you requested it, they extracted it and printed it out on the big-ass green bar paper, and there you go. There's the data you're cleared for. That's what you can go ahead and have. Backups and data integrity were essentially a big part of this job as well. So the fact that you're doing two things, you're making sure that the data is accurate and correct, and you're making sure that the right people have access to it by actually having a human gatekeeper, were things that we don't do anymore. Most likely, if we were to have data custodians, it's only going to be due to the regulatory requirements of GDPR saying you need one. Other things that led to this demise were specifically, let's go ahead and do fast business because we need to data mine everything all the time, every time. So today's fast business essentially requires that, hey, let's go ahead and do this. I'm going to give an API access to every single piece of data I own, sanitized or not, because I need to do these analytics. So we took basically things like AS400s, got rid of them, which gave us a secure repository in which we knew where our data was. It was never going to go ahead and leave that area, and said, okay, it's not going to be structuralized anymore. Let's throw it in a public S3 instance, and let's just see what happens so everybody can access this data and process it without even thinking about it. So why did we do this? Things changed. Internet in general. We have cloud, email, laptop computers. Hell, we have drives that are the size of my pinky fingernail that hold gigs of data, even terabytes. So, not that CIA. Once again, the CISSPs who have this should know what this triangle is. And when you're dealing with data, what does it mean? So I need to go ahead and protect data by confidentiality, making sure that the wrong people don't actually exfil my data. I need to make sure that this data is correct, especially if it's banking records. Geez, I have an 850 credit score, even though I don't, but that's one of those integrity things, which is making sure that you don't tamper with the actual data, because that could actually harm someone one way or another as far as if it's wrong, being bad or good, it'll mess things up. And then, of course, availability, which is, now that I have all this data, can I actually access it knowing that it's going to be right? So people, basically, you need those three things to make sure that your data is straight. So this is the newest concept as far as what people have been doing as far as cloud. They're saying, hey, we need to go ahead and, if we're going to put sensitive data in the cloud, we need to have a data security lifecycle. I find massive flaws with this because essentially we're missing a few things. The thing that I feel is missing the most is this. It kind of could be in that teal thing for destroy, but I think the most overlooked item is actually the retention policies, and the fact that if I got rid of all this data and you're in my systems and it ain't there, you don't have any of it. So you can't take what's not there. But the most dangerous people to your organization are definitely going to be the data hoarders. But I need all those PST files from 20 years ago. Yeah, you can go ahead and ask Sony how that went, especially when there were things of a personal nature in the PSTs that were dumped. So data hoarders are dangerous to your organization, and if that stuff isn't there, they can't actually exfil it. So what happens when I actually can't destroy something? I've developed something that has taken a considerable amount of R&D. So I have to go ahead and protect that data, essentially. The way that you can go ahead and do that is going to be through either encryption or rights management. And once again, you exfil it, it's pretty much not worth anything to anyone because they can't read it. So backups, this is missing from the actual circle thingy that we showed, the data security lifecycle way back. Backups are much more important, as I'm sure everybody's heard about all the nice ransomware that's running around, and I've seen entire R&D VDI farms destroyed and all that work lost. And they thought they were snapshotting, but they didn't. So ransomware essentially can't hold you with a ransom if you actually have the data readily available. Moving on, we'll talk about data classification. I think that this is the absolute key to being successful in any of the actual programs that you're actually going to put together. Because if you don't know what you have, then you really don't know what the hell I need to back up. You really don't know what got exfilled. You have no clue. You're just simply not going to know. So when I properly classify data, and I have my people do it through some type of a mechanism, I basically have the ability to hold my own people accountable for this, because they essentially can't any longer say, well, I didn't know that this was company proprietary information data, and I wasn't going to go ahead and send it. But if I'm forcing my users to actually classify the data, they had to think about it. And if they're going to go ahead and try and circumvent my system and game it, I literally have probably grounds for termination for somebody trying to go ahead and game my system. So when should it happen? It should happen when a data is actually, when a document or piece of data is actually created, and it should be done at the end user level right off the bat. So one of the things I like to go ahead and say is, hey, data is essentially like water. Single file is a single drop of water. But we all know what water likes to do if you've ever had a flood. So now we have petabytes of information. So water is easy enough to deal when I have a drip, but when I get into the ridiculous flooding, the hell am I going to go ahead and do? On top of that, you probably have data that has never been classified in your organization, and it's sitting there on drives, on servers, probably even being migrated to the cloud without even knowing what the hell it is. So that's a lot of things to go ahead and sift through, and you're not going to be very effective. So a lot of companies actually come up to me and go, well, we have storage, we have EMCs, we have all these things, and they're full of data. We don't even know what's on it. How do I go ahead and actually scan? If I took any e-discovery tool with this much data, I mean, I can't even vacuum up that water. The drip I can with a wet dry vac. This much, that's way too much volume. So if I were to even go ahead and take any e-discovery tool out there, and let's say I'm going to throw money at this, I'll throw a bunch of distributed servers at it to go ahead and do my discovery scans. The problem is the formatting of this, which is, we're going to get into, which is going to be unstructured data. Essentially, it's a tidal wave of stuff. There's no way I'm going to be able to scan this. It's going to take forever. And the approach that I would go ahead and do is immediately say, you need to start classifying stuff. And since we know this works like water, I'm willing to guarantee that if I start properly tagging and classifying things, that I'm essentially going to go ahead and that water is going to go where the other water is. And sure enough, if somebody actually classifies something and it's actually my data, that's good stuff that I need to protect, if I find it there where it went to rest, I'm going to find more of it. So you got to start somewhere, and that's the problem. So the benefits of actually doing the exercise of data classification outweigh a lot of things. Yes, it's going to suck for your organization to begin with, because when people get the pop-ups to go ahead and actually, I'm creating this document, I don't want another pop-up. How is this document going to be? Well, yes, I made you take the time to go ahead and classify it, and anything that's a good classification engine should actually start looking for the document that started innocuous, that may not have had any confidential information, but you need to go ahead and actually keep updating the data classification tags to make sure that once I get something important on there that someone might want to steal, it's tagged. So what this gives me an advantage on is the fact that I can do targeted backups because I know I need this stuff. I can do much more accurate discovery, like talking about going through the flood of data by finding where things actually used to live. I can design smarter architecture by actually taking the data and putting it in an air-gapped environment. I can then actually start saying, hey, let's go ahead and put rights management in this and actually start encrypting data that matters, because I know that this is actually really good data. And more importantly, it gives you situational awareness as to where true data that I want to protect is. So there's two types of data. It's basically, there's going to be structured data, and that's your typical databases, and they're usually locked up, and they do have pretty good controls around them. And then you have unstructured data. Unstructured data could be, and the worst one and the hardest one to track is source code or drawings or documents and SCADA. So once everything gets thrown out there, we've even had instances of Hadoop databases that actually are extracts of the big databases, and that's all decentralized now, so we can actually do actual quick clusters of data analysis for business. So the next thing I'm going to go into is, how do I solve this? So in the beginning, I was saying, hey, we have the three things. We have people, processes, and technology that I have to deal with. People are the hardest because, once again, I can't actually get a data classification program in place if I don't have the stakeholders to go ahead and make these people do this. People also control budget. People control your standards and policies, and you're definitely going to need to be able to enforce this by actually making sure that people are following retention policies, people are actually aware of the classification, and they're not your weakest link to your actual security. So process, how do I solve for processes? This is going to cost the company a bit to go ahead and get this going, because I have to educate everybody as to how to deal with data classification. I need to make everybody aware that data classification exists. I need to let them know that there will be repercussions for actually violating this or trying to game things, and hopefully you don't have to do the public executions in the town square, but sometimes you need to make an example of somebody, and boy, did people really shape up once they heard Joey got fired for trying to go ahead and game the system. You're going to have to educate people definitely that you don't keep 20 years of PST files. People, yeah, Brian Krebs, not your DLP solution. So we move to technology, and I'm not actually going to mention any vendors whatsoever. I'm just going to tell you what they are. So we have data classification, which does classification by users, and there should be some type of a machine learning or pattern recognition to the data when it changes. And it should be able to put machine-readable metadata tagging on containers, whether or not there's rights management or not. We have data discovery or e-discovery tools, and essentially what those do is those are used to go ahead and scan your entire on-premise environment. It can be done in the cloud, and that's where some CASB tools actually work. We have data loss prevention, which is typically going to be put into place to actually try and stop data from leaving your organization. So if you look at the bottom where I have it in all caps, data loss prevention, it doesn't work unless you actually block stuff. And the problem with data loss prevention on its own is you have too many false positives and you may disrupt business, and people will absolutely throw DLP in the garbage once it actually blocks a business critical thing. So these are all the technologies. You want to talk about it at the bar, I can definitely talk about what they are out there. I'm not endorsing anybody's product. This is not what that talks about. So if you want to go ahead and be what they call a center of excellence for data, you literally have to go ahead and follow the CMMI data maturity model. It is a Carnegie Mellon essentially scoring system to say how efficient my actual organization is in regard to the way I handle data. The glossy really looks nice, but it is a pain in the ass to implement, and I don't actually recommend that you even go down this path or even talk about it until you have some type of a maturity that's already there for your IT, your networking, and your actual security teams. And that would even bring in your risk and compliance people too. So let's go ahead and do fun tabletop exercise as to what could go wrong. So I had to go ahead and talk to a client, and they just did not actually go ahead and get why this mattered at all. And of course, they wanted to go ahead and do the data maturity model, but they couldn't even understand the first 3 squares. So you take risk, oh, you're not seeing what is on the screen. Give me a sec. Yay, tech fail. So I actually drew these diagrams out because essentially they didn't actually understand it. So the first one that I did in this exercise with the tabletop exercise was, what is your actual risk? What are the areas affected? What are the groups affected? What controls can I actually put into place? So you take the very center of it, which is a threat model, and in this one, which is backups that weren't actually properly done and verified, what would happen if I have a malware attack that did ransomware and locked up all those files? So we finally get to the actual let's reduce risk at the bottom of it, and essentially we move on. So in this particular model, this is a data breach and a mass exfiltration. So what do I want to go ahead and throw as a technology control at it? The e-discovery, DLP, and all those things. And why would I actually care about it? That's under the areas affected. So the next thing is groups affected. I can actually go ahead and break it down by this is your data center, this is your cloud, these are the people who are responsible for this, and these are the people who are probably going to get fired. And then you take the DMM, which basically is the data maturity model, and then there are 10 instances there, but they couldn't even understand the first two parts. So how am I going to get them to data maturity model? It just didn't work. But what I could definitely do is say, hey, we've got a threat model, we've got a threat vector, and we basically have a way of reducing the risk. So moving back to the slides. Yeah. We now go ahead and we want to think about how do I go ahead and build better defenses against these things. So if I understand where my data is, why would I leave it in places that anybody, as far as an attacker, can go ahead and get it? So essentially, when you break into places, you want to get the crown jewels. Your hackers, they actually understand where that is better than most organizations, unfortunately. So when thinking about the way that you actually design things by using additional firewalls, by using choke points to require multi-factor authentication and things like that, you essentially can go ahead and defend or at least try and slow down your attacker. So when we think about architecture, you should be thinking about my good stuff's here, I need to protect it, and what can I do to slow them down? Other people have actually gone as far as to say, as soon as we've detected that we've had some loss of data in a particular area, we pretty much assume that they're actually all in there already and decide whether or not they're actually going to shut down that environment entirely to actually stop them from getting that. So back when I was talking about the history, you want to go ahead and design your architecture to essentially have controls in place so that the data actually stays in a centralized area and it never really moves. So essentially, one of the ways that you can do it with modern day tech is go ahead and take a VDI farm. The data only pretty much rests and resides within that VDI farm, and all your good stuff basically lives and dies there. In your architecture, since I have to assume that when they're finally breaching and getting in there, one of the things you should actually go ahead and do is actually let data that we know that has been exfilled get exfilled, but poison the documents with something like honeydocs. Also, if I understand where my data is, I should have already put in rights management, encrypted it, or actually used whitelists so that you actually have to go ahead and get through things via tight ACLs. So once again, this is your environment an attacker is in. It's unforgivable for you to actually let somebody go ahead and get in your environment and run wherever the hell they want. And if you have the actual devices and technologies that do this, you want to go ahead and enable blocking. So data classification is going to give you some of the latitude because you're not going to have the false positives if you're actually reading metadata tags. Whereas if I have these devices that are supposed to prevent my data from leaving the premises and all it's doing is monitor and alert, that's good. My shit just left. I'm gone. And I can't control the data once it left the building. So another fun part is I know where the good data is. I should know who has access to this. And if I do have the data actually defined, and I know who actually has access to good data, if they fail the company phishing test, yeah, you only get VDI. You don't get internet. You don't get email. You work here because you're an idiot and you failed the phishing test 5 times. So I cannot give you nice things. Essentially, you work there. So other than that, this is about the end of my talk, and I'll field some questions. Yes? I will post the slides, yes. So, did you sneak in here? Were you here early or? Yeah. So, fun part is yeah, I'm going to post this because I don't work for anybody right now. Other questions? Yes.
So when you're talking about the data
Classification? It's more like a, hey, we just don't worry if there's a data custodian. We will have to go ahead and do that, especially if you're in Europe because of GDPR. But as far as the job role of data custodian, no.
kind of follows from that for places that do still employ a data custodian? Or is that one of those roles that just becomes sacrificial in the event of a breach?
So as far as a data custodian being sacrificial in the event of a breach, most of those people who still are in data custodians, the work they do is usually like Lockheed Martin and all the rest. So you don't really hear a lot about breaches because they control that type of data pretty decently. But when they do, boy, is it epic fail.
Some of these other complex projects that have multiple people and multiple companies and so forth involved, and you have all this data in transit.
And of course, we put it in the cloud too. So the only thing we can actually go ahead and do is actually add some rights management layers and make sure that people can't actually get it. This is the biggest problem for actual companies right now who are actually, let's give anybody a device they want, or bring your own device, because I don't want a Windows box. I want a Mac. I want to run Linux. Well, I don't really care what you run if I actually have rights management and you can't open or actually look at any of the data unless you're actually cleared to do that. So that's one of the things that I would say with the movement of data like you just brought up and the sharing and collaboration, that's our last defense, because you take your laptop, you take your USB drive, that shit's out in the open. Nothing you can do.
I didn't catch VDI. What's the acronym?
So they're virtual display environments, dumb terminals, in which basically think of a bunch of VMs on a single server, and that's your dumb terminal, but I can actually run a full instance of Windows. But there's nothing for me to actually plug into it. It's literally a virtual session. So if you think about it, I'm working on plans. Yes, you can use your own damn machine. The only way that there is an attack vector for that though, which is somebody can actually record your keystrokes and your screen. So it's not perfect, but it's definitely going to be better than giving up original documents. Yeah, but it's done. Same as in the user behavioral analysis stuff. Essentially, if you're doing something bad, it's literally going to start recording everything that they were doing to actually prove that somebody was trying to game the security system. More questions? Yes.
What are some good e-discovery tools that you use or that you recommend?
So once again, the e-discovery tools are not actually very effective without actually starting to do the classification. So that's why I was saying earlier, you have to go through the effort of making your end users do metadata tagging with classification. And I guarantee you, if all my users start classifying their data, I'm going to find where the good shit went. So I had a picture of a single water drop. Essentially, a single file is a single water drop, easy to manage, easy to maintain. When I have a flood of data, and we're talking about petabytes of data, I can't even begin to start, and I don't have machines fast enough to go ahead and scan and do my e-discovery, especially when I've got that much data. So what I do is, as you know, water goes where water wants to go, if you've ever overflowed a bathtub. So what I'm hoping to do is actually have people tag it, start following where the good shit went, and then go ahead and focus my discovery efforts where I know things went. Anyone else? Alrighty, feel free to hit me up at the bar. If you have any questions or want to talk vendor-specific things, I have my thoughts about them, but that's not for this place. Thank you.